GM, welcome to another episode of Web3 Academy, your trusted source for useful and legitimate information to remain on the forefront of the internet revolution. I'm Jay Bird, and here at Web3 Academy, we believe that Web3 is going to change the world. And that's why I'm here to guide you, the world's top talent, into this space to contribute, get ahead of the curve, and capitalize on the opportunity. In today's episode, we are talking about the rise of decentralized storage. So in recent years, many of us know that the world has witnessed tremendous growth in the amount of data being generated, stored, and accessed every day. With this explosion of data comes the need for more efficient and secure storage solutions. Decentralized storage is a promising technology that has emerged to address the limitations of traditional centralized storage systems. Unlike centralized storage, which relies on a single entity to manage our data, decentralized storage leverages a network of computers to store data in a distributed manner. This approach offers several advantages, including improved security, privacy, and resilience. So today, we have CryptoShuriken, who is the founder of his own blog and has been writing about Web3 for a while, and he's here to share his knowledge in today's deep dive. Here's what we're going to cover. We're going to talk about what is decentralized storage, why we need decentralized storage, how decentralized storage works, and the options for decentralized storage protocols and platforms. So it's going to be a good one for everybody out there because this is really the basic information. It's not the sexy stuff that gets you to make money. It's not going to get you a new NFT or the next alpha on which token you should be buying. But all of us have data, a lot of data, in fact, online. And we need to all understand how this data is managed and how it is stored, because if we don't, we really put ourselves in position for a lot of risk. So you're going to want to tune into this because it's a really important episode for everybody to understand. Before we jump in, let's just take a minute to hear from our awesome sponsor.
The future of social media is here, and that future lives in Web3 on top of Lens protocol. Web2 social platforms are broken and ripe for disruption. You see, the epicenter of social media is the creators, and yet they are the most neglected. Web2 platforms like Facebook, TikTok, and Instagram are all essentially robbing creators of their worth. Creators are a new type of entrepreneur, forming new types of businesses. Yet with Web2 platforms, creators don't own their content or their profiles, and that's their product and business. Instead, they are tied to the platforms they choose to create on. Well, just like how crypto is freeing us from banks, Web3 is freeing us from these centralized platforms. On Lens protocol, creators own their content, own their profile, and even their social graph and followers in the form of NFTs. This allows you to move freely from one social application to another with your content, profile, and followers moving along with you. Lens protocol enables self-sovereignty for your social graph and interoperability across the internet. At Web3 Academy, we believe this is the future of social, and that's why we've partnered with Lens to ensure that the path of social media is heading in the right direction. Visit lens.xyz to learn more today.
Are you building a community around your brand? Well, listen to this. At Web3 Academy, our motto is community first, profit second. Why? Because engaged communities tell you exactly how to improve your product and ultimately drive growth. They act as team members, recruiting new customers and providing crucial feedback. And they become brand superfans, sticking by you through thick and thin. But to engage your community, you must first understand them. That's where Chasm comes in. Chasm is our go-to Web3 tool for managing and understanding our community members. It combines both on-chain and Web2 metrics all in one user-friendly dashboard. With Chasm, you'll know things like which other communities your members are part of and which of your campaigns are truly driving results. That's why at Web3 Academy, we use Chasm to launch campaigns, optimize growth, engage our community members, and automate workflows with this all-in-one tool. If your community is already on chain, get to know them better with Chasm. Head to chasm.xyz using the link in the description and discover why top brands like Immutable, Nifty Labs, and Collab Land are using Chasm. So, what is decentralized storage? Well, as its name implies, decentralized storage is a type of storage system that does not rely on a central server or authority. Unlike a centralized storage system, which is managed and operated by a single centralized entity, decentralized storage is operated by a peer to peer network of user operated nodes, each of which stores a copy of the data, creating a resilient file storage sharing system. This makes it much more resistant to censorship and attack than traditional storage systems. The need for decentralized storage really comes down to the fact that in modern days, cloud services such as Google Drive, AWS, Dropbox have become the go-to option for hosting files and websites. While these services have helped individuals, startups, and large companies relieve the hassle of managing their own storage infrastructure, the centralized nature of such services presents some deep flaws. One of the many flaws of centralized services is that they are easy to censor. If a government or other authority does not want certain information to be out there, they can simply order the centralized storage providers to remove it and not store it in the future. Furthermore, they can even make changes to the contents of the data stored, resulting in poor information integrity. Now, another flaw is that centralized storage services are vulnerable to attack. If hackers can gain access to the servers of a centralized storage provider, they can potentially access and even delete all of the data that is stored on those servers. Since these services have data hosted on centralized servers, having a single point of failure means any outage can result in temporary or even permanent loss of data. And we've seen this many times. One example that comes to mind was about a year ago when Uber was hacked and a lot of sensitive information was obtained by a hacker. One single hacker was able to get into their system. And once he's in, he can access a ton of their data because of that centralized entity. So it's very concerning. The risks are real. Now, decentralized storage provides a solution to all these problems by providing a censorship-resistant, secure, distributed, efficient, robust, cost-effective, and resilient form of data storage. So, question on everyone's mind, how does decentralized storage work? Well, let me explain. The decentralized storage model works by distributing a copy or a portion of the entire data across a peer-to-peer network of nodes, each of which is incentivized to store the data. By storing data redundantly across multiple nodes, the decentralized storage system ensures all data is secure and accessible. When the same piece of data is stored across multiple nodes, even if a couple nodes go down, the data can still be retrieved from the rest of the storage nodes. So, what's in it for the node operators? Well, we all have unused space available in our computer and mobile device storage. The decentralized storage system makes use of available storage space on the node operators' disks, drives, and node operators are incentivized to rent out this unused storage space on their devices to the decentralized storage networks. Now, let's learn about different decentralized storage protocols and platforms and their inner workings. For starters, we can even consider the Ethereum blockchain itself to be a decentralized storage system. And to some extent, it is for code, smart contract storage. But when it comes to storing large amounts of data, JPEGs, GIF, MP4, a lot of the data that is being used in NFTs, when we think about music NFTs or when we think about image NFTs or art NFTs, it becomes a bit unfeasible, not to mention gas inefficient, since this isn't what blockchain was originally designed for, to store large amounts of data. So we need to look at other solutions that are tailor-made for storage purposes. First, IPFS. So IPFS is a peer-to-peer protocol for storing, accessing, and sharing data in a distributed file system. What does the mumbo jumbo even mean? Well, let's look at an example. We all love Twitter, the little bird app that is so cool. To access Twitter, you put in https://twitter.com into your browser. And since it points to Twitter's IP address, we get what web page the server on that address stores. But if we put Twitter on IPFS, We don't get an IP address. Instead, we get a content identifier, or CID for short, to access Twitter that looks something like this. It's a IPFS address that looks like a wallet address. So instead of finding data by its location, IPFS finds it by its contents. So how does IPFS work? Right now, there's a problem that exists on the internet, that content is found by its location. You want to Netflix and chill? Cool. Go to netflix.com. You want to read Web3 Academy? Cool. Go to w3academy.io. But what if the location of the content changes for some reason? So content addressing fixes this problem. By content addressing, every piece of content has a CID, which is based on the data's cryptographic hash that points to the data in IPFS. That means two exactly similar files will have the same CID. Any minute difference in the content will generate a completely different CID. IPFS uses the SHA-256 hashing algorithm by default to generate CIDs. IPFS uses content addressing to identify and find content rather than looking where it's located. So take a look what happens let's consider what happens when you add a file to IPFS. Your file and all the blocks within it is given a unique fingerprint called a cryptographic hash. IPFS removes duplications across the network. Each network node stores only content it is interested in, plus some index information that helps figure out which node is storing what. And then when you look up a file to view or download, you're asking the network to find the nodes that are storing the content behind the file's hash. So you don't need to remember the hash, though every file can be found by human readable names using a decentralized naming system called IPNS. There's so much to these storage or decentralized storage protocols that each of them deserves a detailed blog post. For example, IPFS uses Merkle DAGs for representing files and directories. But for today, we're just going to stick to the basics in this podcast. Second decentralized storage option we're going to talk about is Filecoin. Filecoin is a peer-to-peer network built on top of IPFS, created by the same team behind IPFS, that incentivizes users to rent out unused storage space by rewarding Filecoin's native FIL token. In Filecoin, users pay for storage space, and anyone who wants to store other users' files can join the Filecoin network and get paid. So here's how it works. I have a device and a user wants to store. The user pays the miner to store their file. The miner commits publicly via Filecoin's blockchain to storing the file. The network constantly verifies that miners are storing files correctly. And then the user pays the miner to retrieve their file back again when they might want it in the future. Let's talk about another option, Swarm. Swarm is another decentralized storage protocol that is part of Ethereum's holy trinity. Ethereum for computing power, Whisper for messaging, and Swarm for storage. Swarm provides a completely decentralized storage infrastructure that allows people all over the world to become storage providers and get paid while doing so. Swarm is designed to be highly scalable and resilient, and to provide a platform for applications that require a high degree of security and censorship resistance. The idea for Swarm was presented by Gavin Wood, and its development is mainly funded by the Ethereum Foundation. So let's talk about a few things about Swarm. First, it's permissionless and private. Second, it's leak-proof messaging made real. This means that the third element of this Ethereum trinity allows for Swarm to be incorporated with Whisper, which is bringing the possibility of truly leak-proof messaging for full nodes. Swarm is also built for builders. It's completely decentralized. It's scalable with zero hosting costs, and it's public interest. Since anyone can contribute to Swarm, it establishes the system for important data commons such as OpenStreetMaps data, and is collectively funded by the public. It's a public good. So what's the difference between IPFS and Swarm? While both protocols may look similar from a high level, there are subtle differences that exist when we dive deeper into the inner workings and philosophies behind these protocols. Some of them are: Swarm's core storage component uses an immutable content addressed chunk store, while IPFS uses distributed hash tables to find which peers are hosting the content. A hash table is a database of key to values. A distributed hash table is one where the table is split across all the peers in a distributed network. Since Swarm is a part of the Ethereum Holy Trinity, it has deep integration with the Ethereum blockchain for the incentive system, whereas IPFS has no incentive system of its own and utilizes Filecoin to add an incentivization layer. From a development standpoint, IPFS is much further along in code maturity, adoption, and community engagement as compared to Swarm. As a result, IPFS has a lot of content available in terms of documentation, whereas Swarm doesn't have a large documentation base. I mean, even while doing the research for this article, we found very difficult to find information on Swarm and had to go through a lot of third-party blogs because their documentation just isn't quite there yet. So there are a lot of similarities and differences between both these protocols. And for more details, make sure you check out our newsletter where we have more links. Next up, let's talk about Arweave. Arweave is a decentralized storage platform that uses a new type of data structure called Blockweave. Blockweaves allow Arweave to offer scalable, resilient, and efficient storage. So, what are Blockweaves? Blockweave is a core technology behind Arweave. We all know that a blockchain is just a chain of linked blocks that contains transaction data. Blockweaves are similar to blockchain in that they are a chain of blocks, but it contains storage data linking to multiple previous blocks from the network. Blockweaves work by enforcing that the miners provide a proof of access to old data in order to add new blocks. Unlike a more traditional blockchain, where miners spend compute power and electricity to compete to mine a block in order to earn tokens, the Arweave network encourages miners to store and replicate valuable data in order to earn tokens. The permaweb. Now, the permaweb, just like the traditional web, is a collection of interlinked documents and applications that are stored permanently. The permaweb sits on top of the Arweave data storage layer. Since the Arweave network is built on HTTP, just like the traditional web browsers have access to the data stored in the network. So imagine you, the users, and then we have the permaweb, which is us accessing the web. And then underneath that, we have Arweave, which is the network that stores all the data. Next, let's talk about Storj. That's STORJ. Storj is a decentralized storage platform that provides secure, scalable, private, efficient, and S3 compatible decentralized cloud object storage. Similar to other decentralized storage platforms, Storj connects people with unused bandwidth and storage space to those who need cheap, accessible, and private file storage. Storj uses Storj, their native ERC20 token, to incentivize people who are renting out bandwidth and storage space. One more, SIA, or SIA. SIA is another popular decentralized cloud storage platform that connects renters with and hosts together in a peer-to-peer network. SIA has its own blockchain, and the hosts get rewarded with SIA's own native utility token, SIA Coin. Once the renter uploads their file to the SIA network, it gets split up, encrypted, and sent all over the world. The network ensures the files are always accessible by making multiple copies of them. And since the files are split up into multiple pieces and encrypted, they're inaccessible to the host. So, in conclusion, with the mainstream adoption of centralized storage networks in the past decade, and with centralized cloud services like Google and AWS providing a fast and cheap storage infrastructure to individuals and organizations, threats of poor information integrity, privacy, and censorship have been omnipresent. The decentralized storage model addresses the issue of centralized storage by distributing the data across a network of distributed nodes, each of which stores a copy of the data. This makes it much more resistant to censorship and attacks with better information integrity and data availability than traditional storage systems. Thanks so much for listening in, everybody. I hope you learned about decentralized storage systems, how they work, and the available options. Look forward to seeing you in Discord, on Twitter, or at a conference coming up. Until then, have a great day. Jaybird out.
Thank you for listening to Web3 Academy. We hope this helps you along your Web3 journey. And if it does, please share this episode and subscribe so you don't miss the next one. Nothing in this podcast was financial advice. Crypto and Web3 can be risky. You can literally lose it all. In fact, if you invest on account of what we say, you probably will lose it all. So don't do that. In all honesty, the point of this podcast is to remove the noise of markets and price and focus on utility and implementation anyway. So you should not take any of this as financial advice. Thank you, friends, and see you in the next one.